in your interactions with the metric system so far, you may remember that you don't always encounter meters, liters, and grams, right? You might have kiloliters, millimeters, centigrams, I don't know, something like that, right? So the terms preceding each of the units of measurement, those are called prefixes, right? And so you may need to do a little bit of remembering, like, okay, how many centimeters are in a meter, that sort of thing. And that's where this nice handy-dandy table that you see on the screen is going to come into play. All right. Now, there's a lot here, and some of these we're not going to use. I'm just including it for your information. The ones that I absolutely need you to commit to memory and kind of know, like, okay, when we use this prefix, this is what we mean, are from mega up at the top down to nano. All right. So remember those, and I guess, so here are the scientific notations that accompany them. And we'll get some practice using these. So when I say, megameters, and that really means that we have, 10 to the 6th meters, okay? And so just as a reminder, oh, yep, we've seen scientific notation before, and we will look at a logarithmic scale perspective in a minute, but before we go on and do that, let's just look at these. So I want you to pause the video and take a shot at each one of these, okay? And so we'll go through the answers in just a moment. Okay, so we want to know if 10 to the negative ninth grams is the same as 10 to the 0 nanograms. Well, here's how I use this. So if I remember this scale, I might need to draw it out, for instance, or something like that. But 10 to the ninth grams, that means from grams, which is my base unit here, I would go down 9 powers of 10, and I would end up right here. Okay, so I would be at, so this side is really 1 nanogram, if I want to think about it like that. Okay, and then this, the right side here, 10 to the 0, that's 1 nanogram. Okay, so yes, these are equal, so this is true. Okay, now for the next one, and you could have gone the other way around, but if I have 1 kilometer, so I'm sitting right up here at 10 to the 3rd, I want to see where I end up on the other side. So on the right side, I have 1 times 10 to the 3rd meters. So I have meters are my base unit here, and I'm just going to call this is always, I think of this as the base. Then I go up 3 powers of 10, which does end up right at 10 to the 3rd. Okay, so this one is also true. All right, then for this next one, when we have 1 meter, I want to know how many micrometers that is, so let's think about that. Okay, so I'm at meters, that's my base unit, okay, and micrometers, given by this Greek letter mu, okay, like cat goes mew mew, when we go down there, I jump down to 10 to the 6th. Or 10 to the negative 6th, right? But now, meter, this is a large number. Or this is a large unit of measurement in comparison to a micrometer. This is small, okay? So it makes sense to me that if I'm saying we have 1 large thing, I need many small things in order for them to be equal, right? So then, it's not necessarily that it would be 10 to the 6th, or 10 to the minus 6. It's actually going to be 10 to the 1 times 10 to the positive 6, okay? So I need 1 million, that's what 10 to the 6th is. I need 1 million of these 1 million micrometers in order to have 1 meter, okay? So one big thing has 1 meter has 1 million micrometers in it, okay? Now, that process of just looking at this thing and learning how to use it doesn't always click for students. So what we can do is look at the same sort of thing from a different perspective, and that's the logarithmic scale perspective that I always think of too. Okay, so what I end up doing is I think of this as a ladder. Okay, and here's my base unit, and this is going to be 10 to the power of 0. Okay, and then if I go and I kind of draw this number line vertically, okay, and I go up one, I'm going to do 9 steps in each direction. 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so then I know, let's see, up at 3 steps, this is my kilo as a prefix, which is 10 to the 3. Okay, and so then I'm really just associating the exponent with the tick mark here, and then up at 6 we would be at mega, m, and then in between at 2 I have hecto, 10 to the 2, and I have deca at 10 to the 1, okay, deci at 10 to the minus 1, and centi at 10 to the minus 2, milli at 10 to the minus 3, okay, and then 4, 5 I don't really have anything. Down at 6 I have micro, 10 to the minus 6, and then down at 10 to the 9 I have nano. Okay, and then this way I can kind of use this scale to count as I do some conversions. So, for example, if I want to convert 10 nanometers into centimeters, all I have to do is say, okay, well, I'm at, and let me change the color of my pen here. Let's change it to blue. So I'm at nanometers, right? And I have 10 of those, okay? And I need to go up to centimeters, okay? So I know in total I go up 1, 2, 3, 4, and actually I'll express that differently. 1, 2, 3, 4, 5, 6, 7, okay? So there's 7 spots, okay? Now, so 7 spots. Okay, so then I know that in my answer it's going to be the original thing, and then I'm going to multiply by either 10 to the positive 7 or negative 7, and this is where we have to do a little bit of thinking. Okay, I want to compare the units. Nanometers is small, and centimeters, by comparison to nanometers, is kind of relatively large. Okay, so in order to make, if I'm saying that the 10 is fixed, I need to take the large thing and make it smaller or have fewer of the large thing. So the way I make something smaller using scientific notation is to have a negative exponent. Okay, so compare the sizes and then decide between a positive and negative exponent. Okay, and certainly, okay, so this isn't in scientific notation since I have 10 to the 10. This would be, 1 times 10 to the first. So then if I simplify this, my final answer that you should report on a test is 10 to the minus 6. Okay? Alright, so now I'm going to erase this scale and I'm going to do the next problem. So 1 times 10 to the minus 3, okay, is some number of milliliters. So I'm up at kiloliters. And I want to go to milliliters, which is right here. So in total, I would go 1, 2, 3, 4, 5, 6. So I move 6 spots. Okay. So now here I'm going to have 1 times 10 to the minus 3. Okay, that's what existed, and then I'm going to multiply by either 10 to the positive 6 or negative 6. I just need to decide which one is it. And it ends up being, when I think about sizes, this is a large unit of measurement, and this is a small unit of measurement, right? So then, to make these things equal, I need more of the small, so I'm going to use positive 6, okay? And then, so final answer here is going to be, when I simplify the powers of 10, 1 times 10 to the third, and that would be my final answer. Okay. Now, this is another way that you can use conversion, is use this scale. You can also just say, like, brute force it and go through it that way. In the next video, we'll actually see a third way of thinking about converting units.